day, folks. I'm glad you are back. It means we must be doing something a little positive for you. So please do like and subscribe and be part of the family. And then you can also get notifications if you turn them on, so that you get the latest that we've made for you, especially for you. Now, we also have to remember we are busy with the WPLSoft PLC programming, which is from Delta Corporation. Now, you basically find out that programming this PLC is almost similar. It's almost similar. I find it as just adaptations between one PLC to another. I don't think it's really different. I haven't seen what I would call drastically different. So now we are going to look at our because we have done the timer. What I want to do now is an application for the timer, which will be, I'm thinking the easy example will be a star delta timer. Remember, in our previous sessions, when you're starting with these basics, we did the direct online, even though we really didn't. I just called it direct online on the heading, but when we're doing it, we just showed you how to stop and start, because basically direct online is about stopping and starting a machine. All right. So now, there is all the other instances where you need to move motors in different direction, one direction forward, another direction in reverse, what will be called a forward reverse starter. All right. But then, because I intend to look at the operation of the timer, I'm going to look at the start delta. Start delta timer is basically start delta starter is basically a method of starting your machine slow, so it can warm up. Once the machine is warmed up a little bit, then it can pick up speed and run faster. And this is because we are dealing with automation here. There's a manual way of doing it with switches, but because we are dealing with automation here, we're dealing with PLCs here. So what we're going to do is we're going to look at the automated start delta. All right, there are different ones. That different companies will do it in different ways, but the basic functionality is the same. All right, it's about starting a machine in star. And then star is little currents involved, little torque turning forces, and therefore the machine turns slowly and it just gears up for operation. It warms up, in other words. Then when it has warmed up, about 15 to 30 seconds or so, after it has warmed up, it kicks in. If it's automated, it will automatically kick in. All right, this is what we're going to do. Let's bring in our PLC. We'll go down and get our WPLSoft there, and then what we'll do is, I want to use this platform before I open a new page. I want to use this platform to basically go to the traditional way of doing the start delta. Now, what the start delta was, I'll draw it here. Let me borrow I seem to have a problem with my, doesn't look plugged. It is plugged. Let's just see. That port is probably having a problem. Let's try something else. Yeah, there we are. So now what I'm going to do is basically I'm going to draw start delta starter the traditional way, which was basically we need, it could be a DC conductor, it could be an AC conductor. So let's assume whatever it is, whether it's DC or I need a pen. So let's get a pen. Now there is our line. Let me rather do something different. Let's rather say, change that color. What's the closest I can get to red? I don't seem to have a lot of colors here. All right. Now we are struggling with this. I will just go. I hope that didn't take too much time. Let me just go to the black pen because I'm struggling to get the color that I want. Now there is the line. Whatever supply line it is, be it a live in the case of AC, be it a plus in the case of DC, that's where we'll have our circuit breaker. So let's say that's our line, and we have our circuit breaker. All right. So this is a circuit breaker, miniature circuit breaker. Now we start with protection, so from there we'll probably think of the overload. Okay, so probably think of the overload. All right, and then from there I will say I still want to protect, so let me do the image and stop. With the cone head, that's the emergency stop. Okay, now this was all about safety, protection, safety. Okay, now we have to really, you can't forget this one, because this is about the protection, this is about the safety. All right, the circuit breaker will limit the current. Okay, it will reduce the current it will make sure, it will inhibit currents that are going to be too damaging to that may be damaging to the equipment. All right, so it will restrict currents to a level that will not be too much for the machine. And then, however, circuit breakers normally have standard values, and you might need a specific value which you set at the overall. So you set this one to the specific value of the motor. The emergency stop, in the case of an emergency, someone has to be able to stop that machine. Maybe the machine is now pulling someone by the hair, or something is hopefully not as bad as that, and then you can hit the emergency stop. So that is safety first. Now we go on and you say, okay, fine, after our safety, we say, okay, let's operate the machine. Now this is about operation. We need a stop, normally closed, spring back type. You might know different symbols, it's fine. Right, this is the stop. Alright, now we want to start our machine. That is a little bit too long. I don't think I've got the space, but anyway, let's try to squeeze it. Okay, the start is an open. Again, it's a press and release type, the spring type, which will spring out. So that's our start. Normally we will start what is called a main contactor. The main conductor coil. Okay, now there are two ways. Let me rather put the M on the other side, because there are two ways of doing this. Either we have a pneumatic type, a pneumatic timer, because remember it has to run in star for a certain time, for a few seconds, and then change to delta. So either we have a pneumatic timer, or we could, this is not both, it's either this, or I'll put it in broken line to say it could be, I put this in the broken line because it could be that, or I put the other broken line to say it could be another relay, timer relay, which is the electronic one, the electronic version. Okay, it will be done different, it will always be done the same. Remember that these could have the same, what call this, voltage specifications, but they could be different. So it will depend on whether this is the main conductor and the timer are actually using the same voltage or not. So these could be wired together, or it might not. All right, so this will depend on whether we wire it together or we might not. So now what happens is that when you press the start, we want something that will hold. We have explained before our concept of latching. So this is the latch, the M. This is our latch, the one that will say, once we say start, it will keep the I can now I don't have to what, I don't have to keep holding the what, the start button for the duration of the operation. All right, so this here is wired across. We've explained this when we're doing the direct line. When you explain find the topic on the latch, we've done latching. So this is basically us starting energizing the main conductor, and then the main conductor is energized with the timer. All right, so the main conductor is the one that carries the timer. Either it will be wired together with the what, with the electronic timer, or it will be a pneumatic timer that is embedded, that is sitting on that conductor. So I put them both, so it's either that or that, not both. All right, all right. So but for now, This is me explaining the old circuits, what people are to get, those people who are actually electricians, but we have not done automation, so they can relate to how we are going to change this to the program. Now we come and say, okay, once our main conductor is happy, what I'll do is, just for space, I'll go up and I'll say this is wired to a timer. Alright, the timer is normally closed in the one position, but it is going to, this is the symbol for the timer, it is going to change, it can swing to the other position there, alright, which is the delta position. Alright, so this will swing this way. Okay, so when the timer counts out, that switch will release from here and go and come and and attach them. So what will then happen is this one here will run, but you make sure there's something called interlocking. I've done a session on interlocking. Go and check on that. It means that while the data runs, when the delta is running, the star cannot run. So you can't have them run together at the same time. So when delta runs, that coil will be energized, so it will break this line so that power cannot come to the star. Okay, assuming of course that our main and our star have got the same have got the same voltage specifications. Then otherwise we have, I will just let it to the other side so that I have space. So then I have also interlocking. So this is an interlock, even though I meant this to be delta, but it is also the symbol for the interlock, so it's a little bit interesting. So now this here will be closed from the star, so that while the motor is running in star, this coil is on and that will break, so you cannot energize delta. So the delta will only energize once the star is not operating. All right, so this is the delta coil, and we wire this. Now it depends. Now if this is a live, now it depends. If these are single phase, all of them, then this will go to a neutral. These differences people must know from electrical training. We have a session on electrical training, so people can go and look at that. I want to stick more with the with the automation, so I don't want to spend more than 5 minutes on this, but I think I'm already beyond that 5 minutes. Now if I go on and say, now this could be live and neutral, but these coils here could be 380 volt coils, in which case it's a 3-phase coils. If they're 3-phase coils, that will be live, neutral, or live X, one live, let's say live 1, and then, or it could be live Y. What I mean is different lives. It could be live 1, live 2, live 2, live 3, or live 1, live 3. So it gets, if it's one live here, it will be a different live there. Alright, that's what I mean there. If it's 3 phase, so it could be single phase, in which case for single phase that will be line and neutral, any line and neutral. And then for 3 phase it will be one live and and a different live. Or also it could be DC, in which case it will be simply a plus and a minus. So those are the options that you have there. So there's various options, and also remember these could also have different coils, in which case you wire them to the appropriate one. Now if it goes to a live, it will need to go through a if it's going to a live, let's suppose I just do this to say if it was going to a live, I'm going to put a break line as an option, then it would need to go through another circuit breaker. Okay, lives are always protected with with circuit breaker. So if it's going to a live, specifically if it's going to a live, it will need a circuit breaker to go with it. So this is basically the idea of how our circuit works. Now the circuit is available to you. You can go back and look at it. Let's see. There are instances where we feel, you know what, this here we don't want to keep it supplied the whole time. So once the motor goes, remember the motor, once you press start, the M energizes. When the M energizes, it comes and latches to keep it to hold the circuit on, so that we don't have to keep our hand there, so that while the timer, whichever one, pneumatic or electronic, so that while the timer counts out, we have this line also closed at the same time. So when M ran, star also ran. So star, when you press start, the M and the Y are going to conductors are going to the M and the star. Y is star is sometimes called Y. Ne? So it's called star or Y. Star or Y. Now, so when you energize, when you engage your start, that and that will close, will come in. Meanwhile, the timer counts out. This timer counts out. So while it's counting out, star is running. The motor is running in star. And then after it is counted out, this will break from there and come here. So the motor now runs in delta. All right. While the star was running, it made sure that the delta could not run. Only when the timer is counted out and breaks there, so there's no power to this one, and it's now here. This has gone back, and now our delta can what? Our motor can run in what? In delta. All right. I hope that is clear. Now let's take this and actually put it in the circuit. All right. So what I will do is, I hope you can take this picture and put it somewhere. I've got it in my head, so I want a simple starter like this. All right. There are different versions. This is training, so you get the other versions as you grow bigger in the industry, as you grow, as you find your niche. But for now, I think I will remove this and then we'll do the programming now. Let's program. Now we need a different tool, and there we go, new circuit, and then we are going to simply say star. Let me say, for me it's still timer operation here, so I'll say timer. How the timer works, let's choose the right one. It is there, SS2. Okay, let's choose, let me see how many we have. I've actually, all right, just see how many we have. We have so many. We've got the SS, we've got I need to make sure, because I've got an SS, now I've got an SS2, so right, I wanted to confirm that. Besides what I was doing, I wanted to confirm this, so that there is an SS different from the SS2. Alright, so yeah, so we have the SS2, we've chosen the SS2. Now we can come and say, what are we exactly doing? What is the file name? This is Delta WPLSoft, and then PLC star to delta. It's called star to delta. It's not called star or delta. It's called star to delta because it starts in star and then goes to delta. So it's not as if you choose. It has to start in star and then go to delta. Alright, so that is what it's called. So there we go. So all you need to do now, I'll have to double click and hope it works, because now my picture is on the way. Alright, so now what we're going to do is we're going to say, okay, we'll remember that we need an overload. So do we wire the overload to the PLC? We can if we want to, but the overloads can be wired separate. So I might not include that part of the what? Of the, so it depends. When it comes to a test situation or to come to a working environment, it will depend on what the preference is. Alright, what the workshop manager decides they want. Alright, what is the best operation? The engineers, what do they decide is the best operation? Some people will have the traditional components sitting out there, no stress, and then they just wire them as they are, and then they just fill the PLC with only what is needed for the PLC. Right, so situations may be different. If we want to show all of it, let's say we want to show all of it. Let's say we want the PLC to control our what? To control our, maybe we've got a PLC that works with what? With AC. You know, PLCs are different. Some PLCs will work with DC only, so this may not apply to them, but some PLCs will work with AC. So you might say, even my overload, I want it to what? I want it as part of the wiring. So you can say, okay, let's include the overload, let's include everything. Let's assume a scenario where you just need to put everything. So we are going to say, okay, let's start with the what? With the mains. Now I'm going to remember the mains. When the mains is off, nothing must work. When the mains is on, then it enables, when you put the mains on, it enables things to operate, but it does not start anything. The mains simply say, now you can work. So let me put a mains. Let's suppose we need a mains. Let me put a mains. So what I'll do is I will introduce you now to what? To internal relays. Remember the wire relays were the output relays that you could wire to. But now we are going to introduce a relay that you cannot wire to. It's called an internal relay. It's only an internal relay in the program. All right. So I'm going to have a coil. I'm going to have, say, okay, my main start. So I'm going to have X0 as my main start. My mains on. Okay. So I'm going to say when my mains on. In practice, it really, for me, this really does not make sense, because if I have a mains is normally a toggle type switch. So it's either it's down or it's up. But if you're going to have a mains on and a mains off, it implies two switches. All right, it implies two different switches, which is a little bit of redundant. Components can be very expensive. So I don't think it's I personally wouldn't prefer it that way. But I would understand people who do. Is we can't all go one way. We're not water. So what we'll do is, even water tends to have confluences at points. So now let's have X0 as our mains on. That would imply now that I need to have a mains off. So now the mains on, what I'll do is I'll use an internal relay for a mains that I'll call M. All right, let's call that out. Okay, I'll type out and then I'll just say M. That is the internal relay for this PLC. The mains relays are called M. What I do? Oh, no, I made a mistake, but it's fine. What I'll do, I will go and say, can I do that? Yes. I will say load. For now, I want an input. I don't want an output relay. So I said out, so I don't want an output yet. I want an input that is controlled by the latch. I want the latch for the main. So this will be load M0. All right. Then now I'll come and say it's a latch, so it must just be around the mains on. All right. What then happens is this: I want to have a mains off. So a mains off, in practice, a mains off would have to be, it depends on what switch you have. Normally closed or normally open depends on, you will see as we progress. I think I'll explain that at a later stage, because when you have a normally closed switch, things work different. And a physical switch that is normally closed, things work different. I've explained this before when I was explaining the stop, but I think we will get more acquainted with the concept as we go along. So then let's have our mains off. What I'll do is I'll use a normally closed now. So what I'll say LDI. I just typed. As long as my blue box is in the spot, I just type LDI and I'll call my mains off X1. Now there's my mains off. I forgot to name it. I will put a note to remind me that it's a mains off. It's just a reminder. So I'll come there and say this is my mains off. Alright, so now I'll then go and say this is where I want out, where I'd hurry to say white M0. I meant to put it there so that we have an output coil. Now unfortunately I've put the picture in the, can I move this picture now during record? Let's see, hopefully yes. Let's put it somewhere down there, because I don't think I'll get down there. Alright, because now the problem I have is I can't see my outputs. I want to see my output. There's my output. Now I'm happy. So we come back and say, okay, so now what happens now? This is the main. So it means this is the one that should enable or disable everything. So what it means now is every other line must start with MO. So what I'll do is now, going forward, every line will start with MO. MO, not O, M0, right? So now, if I energize them, that is closed, power goes through, it comes in latches. Go and look at the section on latching. If you can't remember it, now everything else will start with MO, so that if this is enabled, that will allow power to go through to the rest of the circuit. But if this is disabled, whatever is in front of it will never work. So as long as every run is not going to start in MO, we're all going to be super happy. Now we're going to say, okay, now we want the start for the machine. So we're going to say load, and we're going to say X2 now. That will be our start. X2, okay, and I'll call that my start for the start delta machine. Start, okay, and then I will say it's a normally open for a start, and I'll say, but before I do this, let me load all my protection first. Remember, I started with my protection first. I said the mains is there, all right? Now what I need next is the mains. I'm taking my circuit breaker to be my mains. I'm using my circuit breaker as my mains. Right now the overload, I'll come and say now I'll put an overload. Overload is normally what? I'm gonna put a normally closed LDI. Then I'm gonna call it X2. Then I forgot to put a comment there. It's not, oh, okay, I already know this start. This I want to change to. I said cancel, though I don't understand why it kept it there. Anyway, we want this to be the overload. I'll just say OL. Alright, overload. Now, that is my overload. So now if there is a break there, everything from in front there must stop. Ne? I want to also have my what? My emergency stop. So what I'll do, I'll put another one, LDI. Normally closed again. And then I'll say X3. X3, again, another variable input. So we'll wire the overload to this, to X2. Now we'll wire our emergency, didn't name it, our emergency stop. I'll just call it ES, emergency stop. Alright, this is for, you'll wire the emergency stop to that input there, X3. What do we have? Protection. We've got I've said I will use, because now this is tricky, because this will open like I have two inputs, whereas in our original situation there we had one mains, which was the main circuit breaker. Now it means with this kind of situation here I have two, so it's a little bit, for me, I wouldn't do it like this if I had a situation like previously. But for now, just to be consistent with what most of our theory situations give us, we'll see when we do the workshop. But that this is not everything we do in theory is necessarily done like that. We don't deviate much from it. A person who understands the work should be able to adjust easy, but things are not necessarily done the same way in practice. It's not totally different. It's just that probably the theory would have presented a certain scenario that is not really practical for a certain practical space. All right. So if you understand the work, however, you should be able to modify and do everything. So this is especially for my TVET college guys, we would do the NCS course. This is how it's done there. So I want to accommodate that. But in practice, really, I would say I wouldn't have done the mains like this. Honestly, I wouldn't have done the mains like that. But I know from a practical environment that I don't want to have too many unnecessary components. You know, it makes the environment a little bit more expensive. You know, in your designs, you try to take cost into consideration as well. All right. So simplicity. You might try to make your design as simple as possible. One, and you must. These are the rules for actually for designing. Your design must be as simple as possible. All right. That's why even in mathematics we bother you with the simplest form. We always want the simplest form. Even in industry, we want the simplest form. All right. And then also we want what? We want our designs to be as cost effective, as cheap as possible. All right. Because obviously cost gets into what? Into profits. All right. Industry is about profits. So then now we go on and say, okay, we've had the overload, we've had the emergency stop. Now I will say, okay, let me have my stop now. So my stop is going to be X4, load X4, and I'll call you. In the comments there, I will say, I didn't hit the comment. What did I? Okay. I thought I hit the comments. So that will be stop. For me, I prefer to do this as simple as possible. I don't want to have too many lines that are going to get very, very congested and confusing there. Now, it's different from PLC to PLC. Some PLCs limit you on the number of components you can have in a rung. All right. So all PLCs will do that. So you have to be sure that you don't exceed. If you seem to exceed, then you have to You have to basically go and change your program somewhere and modify what it can be. You do extensions, run extensions is possible too. I'll look at run extensions at a later stage. I think I'm remembering it now, so let me note it that I should look at run extensions. Alright, I'll remember when I look at this video. I'll remember. Now, so the stop there also, it was named wrong. It's supposed to be LDI because it's it's a normally closed. It's because I hype it. I know that this will be a normally open. But like we said, we'll catch up later when we do the practical. Right now, we can start our machine. So there finally we have start. So you can see already we have four components there. We've got 4 items on that rung, and some PLCs won't take that. All right, but let's assume that the one that we're having now is going to take it. Let's go on and say, what about our start? Our start is going to be normally open. So let's say LD, sorry, and then let's say X5. I just be going in sequence, even though if you go to a practical workshop, you may find that these things already have their names. You may find that X4 is already on an overload. Then you can't change that. You have to wire according to what you have on the station. Here we don't have any specific scenario that you are programming for, so we do whatever we want. But in a practical environment, you have to double check that each component that you are naming there actually corresponds with the work environment. All right. So now we're going to say our start is X5. In this case, we're not limited. So we say start what? We start the mains. Now remember, not the mains as in the mains, the supply. Here we are starting the what? There. I forgot here to actually indicate this. This is the mains. Mains. We forgot to name. It's okay. It's all best practice to actually name these things so that you, when you are following your program, it's easy to check what's going on. All right. All right. So now I'm going to say, now I want to start M, the main conductor. This is not the mains as in the supply, but this is the main conductor. So what I'll go out and do, I'll say out. I don't need it to be a physical thing, this one. Why? Because I just want to do I want it to control the timing only. So I don't need a physical mains conductor in this case. I want something, because the job of the mains in that situation was to hold the what? Was to hold the circuit 1, and 2, it was also to what? To carry the timer. All right. So now in this case here, we don't need that. The PLC can do that within the software. So we're going to use again M1. Why? Because it's an internal relay. It's already we are saving. I mean, if you know the cost of conductors, and depending on how big the conductor is, how big is what is this current capacity? What size motors are we dealing with? It can be a very huge conductor, and it can be very expensive, and can add to expenses. All right. So if in this case the PLC is eliminated, not only the conductor, the timers are also expensive. These pneumatic timers are very, very, very expensive. So the cost can get explosive if you're going to if you don't control your command. In this case here, the PLC is enabling us to what? To cut down on the what? On the number of components. Even though someone will say, but the PLC stuff is expensive, but the PLC is very versatile because it's got many other uses. So PLC, I think the cost is justified. All right. So now we come and say, what we want here, I want to latch once the main conductor is on. This is not a physical conductor. This is an internal relay. Once the mains relay, all right, I'm used to the word conductor, but once the mains relay goes on, I want it to latch. But this is soft. This is a soft relay. It's not a physical, it's not a hard relay. It's not a relay that you're going to hold in your hand. This is a soft relay, so we call that, we already called it M1. And we said M1, oh, I didn't say load M1. And then we say that there is our mains, our main conductor. Okay, our M, I'll just call it M. No. Calling M1 and then calling it M. Alright, let me say our main, I'll call it main relay. Main relay. Alright, then that is what we are going to use to hold our timer. So we come there, we close that, we choose the line that goes down. I could have written F9 if I didn't want to do it like that. Then I come in and say, but my timer can run at the same time with the what? With the what call this? Main M1 main relay can run at the same time. It's supposed to energize the what? The timer. So I can come and say TMR, AMR, and then I can say I will use T0. Then I'll remember when you dealt with the timer there that is resolution, and T0 to 263 is all 100 millisecond resolution. So to get, let's say we want this to run for 15 seconds, we are going to say 150. All right, 150 is going to give us 150 times 100, which is 15,000 milli. The 1,000 cancels the milli, and therefore we've got 15 seconds. So I'll say for 15 seconds, I'll say K. Remember, we have to identify it as a constant. 150, and once we say okay, there we have our timer. It's fine to leave it like this because these two are basically wired together. Alright, once there's a wire between them, these two are wired together. So the M1 relay is actually in parallel to our timer relay. So now when we energize this, our timer is going to count up to 150. And then now, let's say now, what do we then do? I am not going to come and start here. If I'm going to start here again, I'm going to need to put the M again. I'm going to need to put the overload again. I'm going to need to put the emergency stop again. I'm going to need to put the stop again. So I will come and start here. But I don't want to keep putting these things repeatedly when it's not necessary. So I'll come and start there. So I've got that one line, that one rung controlling this for me. So I'll come then and say, okay, once my timer, the normally close of the timer, LDI, okay, of T0, which is the normally closed contact of the timer, T0 will then run my what? My delta contactor. So let me call this. I don't know if I have to do this because it's obvious there. I might say 15 seconds delay there. 15 seconds. Oh, what did I do? 15 seconds. I don't even know if it's necessary because as long as you look at it and you see T0 and you see K150, it already tells you 15 seconds. But do you feel like it? No, I'm done. We lose nothing. So 15 seconds, and then what does it say? I want this to run the what? But while this is going to run the star, remember we're starting star. So while it's running star, I want to remember that I have to have an interlock in the case when delta is running, my star cannot energize. So I will remember that I've got it normally closed. You can refer to the diagram if you copy the diagram. Normally closed of there. Since this is going to be physical relays, I'll call Y0 for the start because this is a wireable one, so it's a wireable output. Remember the output Y's are wireable, so I'm going to call it Y0. So Y1 will be my what? Y1 will be my delta. So I'll say Y1. Simply to say when delta is running, I don't want to be able to run my star. Alright, so I could have called this delta as well there, just to remember that delta must lock out the star. So delta must lock out the star. This is again, remember that it's called interlocking. Oh, okay. Right. So now I can say, okay, I want my output out, and that output is Y0, which is there. Remember, I can start again there, which is the star. I'll name it, it doesn't matter. So this here, I don't want to start and put all these things again here. For me, it's redundant. I mean, it puts so many components there that will make the picture look a little bit clustered and took, already they say 3 is a crowd. So hey, more than 3 is even worse than a crowd. I don't know what you call it. It's, so what I'll do then, I'll throw another one down there and say, when my timer is running, when I energize and the timer starts running, that is closed, and my Y0, which is the star, is energized. Then after this is counted out, I want Y0 to de-energize. So this will happen here. After 15 seconds, this will break. But at the same time, I want to energize, so which is T0, load T0. And I want that T0 to what? To start the delta. Now the delta contactor. Now this here, while the star was running, we don't want to be able to start delta, so we interlock and you say load in I and then LTI, and then we say what is it? It is a Y0. We want the normally closed of Y0, which by the way is our star contactor, okay, or star relay. So that there will be, I use relay and contactor interchangeably, although in practice they're two different things, but in theory, let me say, they are different, yes, but electrically they are the same. All right, they are physically different, but electrically they are the same. All right, so it's size, robustness, application where they can be applied, Relays are very, very gentle, and they need very low current situations, and then conductors prefer the heavier current situations. But electrically, they are the same. It's a coil. It's a what calls electromagnetic switches. A coil that is controlling some switches. So both of them are literally are electrically the same. Now, so when star runs, this will not, the delta will not be able to run. So let's now have our delta output, and then that will be Y1, which we already called delta, so we are fine. So now that is what we have, and this should run. So until we hit stop, this is automated. You start. Oh, there I didn't say start. This is the start. I didn't call that start. This is the start of the operation. This is our push button, the start button. This is the start of the machine. All right. The main start and the start of the operation is two different things. So let's see if this works, and I guarantee it works. But anyway, let's put to simulation. We then say debug. Now you can see all the closed ones. In practice, remember, things may change. Why? Because some of these are already by default as components, they're already closed. So whatever is closed is going to come and be open here. All right. Whatever is closed already will have to come and be open here. Like the overload will have to be open here. The stop will have to be open here. The emergency stop will have to be open here. Because by design, they are already physically they are already closed. All right. So when you load them to PLCs, they'll give the wrong signal. They'll give the opposite signal. Here, if this will be true if all the physical components were normally open. All right. Let's go and start this. All right. See if there's anything wrong. I don't see it. Let me go and let me stop the debugging. Let me put it online. Now you can see it's ready to start. I come there and say run. He says nope, I need my mains to be on. The mains is not on, so I'm not running. All right, so now try and start the machine. There's F5, energize F5, set on. You can see it's on there, but because the mains is not engaged, there's no way this is gonna go on. All right, now you come and say okay, it's not working. Let me go and put what? Let me go and put my mains on. My mains on, this one is assumed to be a normally open press and release switch. So set on, and what did I do? Did I put this on run? No, it's on stop mode. Okay, it's on stop mode. So let's go, and I'm seeing it's on stop mode because right there we didn't put it on run. Okay, set off. So we are going to have to repeat the experiment. Yes, I want to go on. Now it's on run mode. Yes, now you can see it still won't work. Set on. Why? Because the mains is not on. I come and I release the what call this, the start. I release the switch button. I'm confused now. Why is it not running? Oh, the mains is off, Mambara. So what do? I go to the mains and I say go on, set on, and now you see the mains says I am allowing power through now. Now you can do your thing. Even though I release my, if there's a press and release button type of mains, which is I haven't seen it. I haven't seen it in practice. So now this here is going to say, okay, I'm on. I kept myself on. So yes, I'm ready for you to operate. Now we operate the machine. You say, okay, now you understand the concept of the mains. I can scroll up because my pictures are again on the way. Maybe I should move that side. I'll keep running. So what you can see. Rather I run, okay, than you run away. So now we can see they start delta. So we have the whole picture. So now we can say they start. It must, if it works, the mains and the timer must start working, and this guy star is on. No, there's something wrong here. Did we say start? We didn't say start. No, something's wrong here. Something's very, very wrong. Yes. If you remember our diagram, this here, once the mains is on, it must, once this is on, it must enable the rest of the circuit. So already I can detect a fault there. That is faulty. It's not working. Why? Our star is running already. Our star is not supposed to be running yet. It's supposed to run when we say start. When we say start, what has happened? It's fine to make these mistakes. It is fine, very fine to make these mistakes, as long as was. Remember, as you, especially me, I'm programming and I'm talking at the same time. So sometimes to do to multitask with the brain, it can be a little bit of a challenge. So there's nothing major. All you need to do is just see that there's a problem here and fix it. We probably didn't think hard enough. So once our mains is on, our mains, these two normally closed, cannot come direct from the what? From the closed lines there. It must come, we must have this controlling. We must have the M1 controlling. I prefer that I put my LDI there, Y1 normally closed there, and I change this to the T0, okay, and then I change this to the M1, M1 normally open, M1. Why? Now when this energizes, this will what? Allow power to go through, not before then, not before the start. So what I could have done is I could have taken this line here, I could have taken it, let me rather use a pen so that people see what I'm talking about. I kept saying this line. I could have taken this line here, I could have taken it there, all right? Then I wouldn't have had to put that one there because already it's controlled by it's on the other side of the start. So I could have taken all these and just drawn them from that point there, okay? Even though it doesn't really affect him. Why? He can never go on until the timer says so. So I don't have to move him, but that one definitely had to what? Had to move to after the start, okay, not before. So I hope you understand that little, we overlooked that little thing there. So all you do is come and say, are we happy now? Now I'm sure we are happy. Otherwise we'll start looking stupid. So let's come and say, let's try again. Let's check if there's a critical error there. Nothing. All right, let's come and say, come out of debug. Let's put it online. And then now you see now it does not, even if I say run, okay, yes, we don't have our star running. That was the little mistake here. This guy was supposed to hinder the direct connection to the star. Now when you say start, it will still not work because the mains is not set on. So that part of the main still works perfect. Set off. So we have seen this. Now we come and say, okay, mains on. Only when you say mains on, we don't have to hold the mains button down, and you can see it stays on, latches on. Now we can come and say start, which is what we wanted to see. Set on, and now you can see both the M, which is not variable, just internal, to both the M and the star went in. We've got that situation of yesterday where our scan time is a little bit fast. What I'll do is I will stop this and I will just run it without debugging it. Let me just put something there. LDI X0. I'll remove it. I just want to make sure that it treats it as a new program, because I want to assume that it's still loaded in the system. So I'm just doing that for that. There's nothing here. There's nothing. We don't need this. All right. So what I want there is to just run it without what? Without debugging it. It somehow changes the time there. This is what I'm seeing with this PLC. So yes, I want to compile the program. Yes, it will tell me it's not consistent with the PLC, but I want to do it anyway. So now turn my mains on. You can see my time is now better there. That's what I've figured so far about the time. I will check on the settings of the scan times. But we control it. I don't want it to be going on like that. So we say mains on, and oh, I did not run. Okay, I'll leave the mains on. I'll say run. Yes. Now because I said mains on, it went on. Set off. Now we are where we were. Let's try again. It worked, but it was a little bit too fast because of the scan time. So now we want to set on. Now you can see it counting nicely because it is a better thing. So it's taking time there. You see your star is on, even though it was I released my switch. It's going to go all the way up to 150. It's still running in star. So the star contactor was energized. Now it has changed to delta. It can stay in delta until Jesus comes or the machine breaks, or or one problem or until we hit any of the other controls, and then or we will say stop ourselves. So we opt to come and say, we can see it's running, it may take forever. So yeah, I will have to look at the settings for the scan time, because we can't keep having to do this every time we want to run a program. It's a little bit of a frustration. All right, so for now, this is the start Delta. You saw that when you started, you can start again one last time. So now we can say stop. So we come to X4 and you say okay. On X4 we say right click on that and say set off. It did not set off. Oh, it's off. I must set on. Remember, I'm activating the stop, so it's already on off, by the way. So I must set on, so you can see now it energizes and breaks there, and everything else falls away. All right, but the mains is still ready. You can still remember the mains. You only trip it when you're finally done. But if I'm operating, I can come back and say, okay, I'm not gonna hold my stop button forever. So I'm gonna come and set it on. Set it off. Okay, so it goes back to the state, and now we are ready to start again. So when you say start, you can see your motor is initially running in what? Your motor is initially running in star. This is not wired, it's not a physical relay, so we have eliminated the relay from the from the actual field. Now this is the star, this is an actual relay. A Y is an actual output. Yes, you can see changing it to Delta there after warming up, after our 15 seconds. So as long as our timer is set correctly. So there is the first application of the timer. I hope you enjoyed it. If you did, show us how much you liked it by hitting that like button there. If you are not part of the family and you just joined us, please remember to subscribe and turn on notifications so that you can get the latest from us. And then please comment again and tell us where you're watching us from. We want to see people from Pretoria, want to see people from the Kaap Af, van the Kaap Af. Okay, want to see people from Bloemfontein, PE, where are you? Want to see people from across Africa, want to see people in Europe, want to see people in Asia. One globe. All right, I will see you when I see you. I hope you had as much fun as I did. Time to say bye.